Imagine you wake up tomorrow. It is 2025, October 10th. Everything seems normal at first. The sun rises, the birds sing, but then you notice small, strange things. Your phone's compass app spins in a confused circle. An old-school magnetic compass needle drifts aimlessly. You check the news. Reports flood in from around the world. Stunning auroras appear over a tropical skyline. Vibrant, out of place. Aurora over Panama, aurora over Singapore, aurora over Kenya. It's beautiful and deeply unsettling. Your phone flickers, the signal dies, the internet goes down. People ask questions, voices full of wonder and dread. A calm, steady voice on an emergency radio broadcast, one of the few things still working. The message is simple and staggering. Earth has lost its magnetic field. So, what is this magnetic field we've suddenly lost? Think of the Earth as a giant, slightly messy bar magnet. But this magnet isn't made of solid magnetic rock. It's generated deep within our planet. The Earth's core has two parts, a solid inner core, a liquid outer core. That outer core is a superheated swirling ocean of molten iron and nickel, hotter than the surface of the sun. The planet's rotation causes this liquid metal to churn and flow in massive, complex currents. Moving electrical charges create a magnetic field. This is the dynamo effect. It extends tens of thousands of miles into space, creating the magnetosphere, an invisible bubble around Earth. It has a north and south pole, close to, but not exactly, at the geographic poles. That's why a compass points roughly north. The magnetic field is our cosmic bodyguard, deflecting charged particles from the sun and high-energy cosmic rays. Some particles get trapped and funnel toward the poles, lighting the sky as aurora. If aurora suddenly appeared at the equator, it'd be the first visible sign the shield was down. Earth's field weakens, shifts, and even reverses over thousands of years. Life survived past reversals, but modern civilization hasn't lived through one. A sudden total loss would be far more extreme. In the first few hours after the magnetic field disappears, the most dramatic effects hit the sky and space. Our vast fleet of satellites designed to operate within the magnetosphere's protection is suddenly exposed. High-energy particles bombard sensitive electronics, causing glitches, data corruption, and permanent damage. Within hours, many begin to fail. Global communications, GPS navigation, and weather forecasting go dark. Aviation and shipping feel it instantly. Controllers revert to older, less efficient methods, slashing flight capacity. International calls and satellite-routed internet cease. We become technologically deaf and blind beyond the horizon. Then comes the ground threat. Without the shield, coronal mass ejections become far more dangerous. Geomagnetically induced currents surge through long conductors, our sprawling transmission lines. Large transformers overheat and fail catastrophically. A major storm could trigger cascading blackouts across entire continents. Backbone transformers are custom-built, massive, and slow to replace, months to years. The sky glows with eerie light while cities below go dark. Life does not end in a flash, but the world has fundamentally changed. As the days turn into weeks, the full scope of our technological dependence becomes painfully clear. The global financial system grinds to a halt. ATMs go offline, credit card transactions stop. Without tracking, payments, or coordination, supply chains fracture. Shortages ripple through stores worldwide. Air travel becomes limited and risky. Radiation on high-altitude routes rises sharply. Sensitive avionics face higher failure rates. Global travel shrinks. Forecasting degrades without satellites, less warning for hurricanes, tornadoes, and severe storms. Vulnerability to extreme weather increases. Agricultural planning becomes guesswork. In response, we harden infrastructure. New satellites with heavy shielding and radiation-hardened components. Utilities add protective devices to block damaging currents. We lean into fiber optic networks immune to electromagnetic interference. Some tech gives way to robust, older methods. A great regression, then slow rebuilding. Life under a naked sky, biological consequences. Many species sense Earth's field, a biological compass. Sudden loss would disorient migrants, birds, sea turtles, salmon, and insects. Missed breeding grounds could cause population collapses and ecosystem ripple effects. Pollination drops affect plants and crops. Predators suffer downstream. Some species may adapt using other cues, but adaptation takes time. For humans, increased radiation is the direct risk. The atmosphere still blocks most, yet surface dose rises. A chronic low-dose increase elevates cancer risk over decades, especially at high altitudes and on flights. Energetic particles can deplete ozone, boosting harmful UV. raising skin cancer and cataract risks, harming plants. Across years and centuries, gradual but profound changes unfold. Governments issue safety guidelines, shielded schools, hospitals, and buildings appear. Farming practices evolve to protect yields. Solar wind strips light gases slowly. Earth's gravity retains heavier gases, not a Mars-like collapse. Past weak field eras show life's resilience. The far future looks different, not lifeless. Humans are adaptable problem solvers. Faced with this challenge, we act. We harden technology, adjust behaviors, and protect the vulnerable. New satellites gain robust shielding, heavier, pricier, but survivable. Layered systems with ground-based backups and revitalized undersea fiber. Early warning from sun-watching observatories buys precious hours. Grids deploy GIC protection and stockpile transformers to cut recovery time. Dosimeters guide exposure. Airlines redraw routes and lower cruise altitudes. Conservation aids disoriented species with protected corridors and queues. Can we bring the magnetic field back? With current technology, no. Planetary engineering, nukes in the core, giant space magnets, is far beyond our capability. Our path is adaptation. Shield our tech, protect our people, understand the new environment. From shock to science, fear gives way to action. Life has endured weak field eras before. With clear science, cooperation, and ingenuity, we can meet this challenge. The sky might change, compasses may fail, but life goes on. Let your shock point you to the science, and find a steady path forward, in knowledge and in hope.